Far below the surface, in places where no wind has ever blown, the Earth has been sculpting in perfect darkness for millions of years. There are chambers beneath your feet right now, vast and silent, where water has been carving stone with a patience that defies comprehension. Cathedrals of rock, hidden from the sun, decorated with formations that no human eye may ever see. Tonight, we are going to descend together, gently and slowly, into the quiet world of caves, where time moves differently, and where the only sound is the occasional whisper of a single drop of water falling through the dark. Welcome to Let's Learn While You Sleep. Tonight, we leave the open sky behind and journey inward into the oldest galleries on Earth. Caves are among the most mysterious and least explored places on our planet. Even now, in an age of satellites and deep-sea submersibles, vast networks of underground passages remain unmapped, unseen, waiting in their ancient silence. Some caves are young, barely a few thousand years old, carved by rivers that still roar through their passages. Others are unimaginably ancient, hundreds of millions of years in the making, shaped by forces so slow and so patient that the human mind can barely grasp their timescale. In these hidden spaces, crystals grow to the size of trees, entire ecosystems thrive without a single ray of sunlight, and the very concept of day and night loses all meaning. So let your body settle now. Let your breathing slow. There is nowhere you need to be, and nothing you need to do. We are simply going to wander, together, through the dark and beautiful architecture of the underground world, and let the quiet of the caves carry you gently towards sleep. To understand how caves are born, we must begin with something deceptively simple: water. Rainwater, as it falls through the atmosphere, absorbs a small amount of carbon dioxide from the air and from the soil it passes through. This transforms it into a very weak solution of carbonic acid, something far too gentle to feel on your skin, but powerful enough, over millennia, to dissolve solid rock. Most of the great caves on Earth are carved from limestone, a sedimentary rock composed largely of calcium carbonate, the compressed remains of ancient sea creatures, shells, corals, and the tiny skeletons of organisms that lived in shallow oceans hundreds of millions of years ago. When this mildly acidic water seeps into cracks and joints in the limestone, it begins to dissolve the rock along those fractures, atom by atom, molecule by molecule. At first, the openings are almost imperceptible, hairline fissures no wider than a thread. But water is extraordinarily patient. Over tens of thousands of years, those fissures widen into channels. The channels become passages, the passages become tunnels, and eventually, given enough time, the tunnels open into great chambers, vaulted rooms of bare rock that may stretch hundreds of meters in every direction. This process is known as karstification, and it is responsible for some of the most spectacular landscapes on the planet, both above and below the surface. In regions where the limestone is thick and the rainfall is abundant, entire landscapes can be riddled with sinkholes, disappearing rivers, and blind valleys, places where streams simply vanish into the ground. Beneath these features, hidden cave systems extend for extraordinary distances. The Mammoth Cave system in Kentucky, for example, is the longest known cave system in the world, with more than 670 kilometers of surveyed passages, and explorers believe there may be hundreds of kilometers more yet to be discovered. All of this, every passage and every chamber, was carved by nothing more dramatic than slightly acidic water, moving quietly through stone, in total darkness, with all the time in the world. Once a cave has been hollowed out, a second and even more beautiful process begins: decoration. The same water that carved the cave now begins to adorn it. As mineral-rich water seeps through the ceiling of a cave and meets the open air of the chamber below, it releases a tiny amount of its dissolved carbon dioxide, much the way a carbonated drink fizzes when you open the bottle. This slight chemical shift causes a minuscule deposit of calcium carbonate to be left behind, a ring of minerals so thin it is nearly invisible. But over years, decades, centuries, that ring grows downward, building upon itself one imperceptible layer at a time, until it becomes a stalactite, a slender, tapering column of stone hanging from the ceiling like an icicle made of rock. Where the water drips to the floor below, it leaves another deposit, and a stalagmite begins to grow upward to meet it. In some caves, stalactites and stalagmites eventually join, forming complete columns that stretch from floor to ceiling, pillars of stone that took hundreds of thousands of years to build. The rate of growth varies enormously depending on the local chemistry and water flow, but a common estimate is that stalactites grow roughly 1 centimeter every century. Consider that for a moment. A stalactite, 1 meter long, may have taken 10,000 years to form. A great column several meters in height may represent a span of time reaching back to the last ice age or beyond. And yet these formations are only the most familiar of cave decorations. There are also flowstones, smooth, cascading sheets of mineral that drape over cave walls like frozen waterfalls. There are cave pearls, small rounded spheres of calcium carbonate that form in shallow pools where dripping water keeps them gently rotating. There are helictites, perhaps the most enchanting of all, which are thin, twisted formations that seem to defy gravity, curling and spiraling in every direction as if guided by some unseen whim. Scientists believe helictites form when capillary forces, rather than gravity, guide the movement of water through microscopic channels in the crystal. Now, let us descend deeper, past the familiar world of stalactites and flowing water, into a realm that seems almost alien. In the year 2000, miners drilling beneath the Nika mountain in the Mexican state of Chihuahua broke through a wall of rock and stumbled upon something that no one had ever imagined possible. They had discovered the Cave of the Crystals, a chamber roughly 30 meters long and 10 meters wide, filled with enormous selenite crystals, some of them reaching lengths of over 11 meters and weighing as much as 55 metric tons. These are among the largest natural crystals ever found on Earth. The crystals formed over approximately 500,000 years in conditions of extraordinary stability. The cave sat below the water table, filled with mineral-rich water heated to roughly 58 degrees Celsius by a magma chamber far below. At that specific temperature, the dissolved mineral gypsum was able to precipitate out of solution and slowly accumulate on the growing crystal surfaces, adding layer upon infinitesimally thin layer over hundreds of millennia. The result was a chamber that looks like something from a dream. Translucent beams of crystal crossing the space at every angle, glowing with a pale, milky light, each one perfectly smooth and geometrically precise. And yet this place is profoundly hostile to human life. The air temperature inside the cave hovers around 50 degrees Celsius, and the humidity approaches 100%. Without specialized cooling suits, a human being can survive inside the Cave of the Crystals for only about 10 minutes before the body begins to overheat. The lungs struggle to function in air so saturated with moisture that it can barely carry oxygen. It is one of the most beautiful places on Earth, and one of the most dangerous. Since its discovery, access has been extremely limited, and in 2015, the mining company allowed the water table to rise again, reflooding the chamber. The crystals now rest once more in their warm mineral bath, growing imperceptibly, as they have for 500,000 years, in silence and in darkness, with no audience at all. If the Cave of the Crystals speaks to the power of heat and mineral chemistry, then the caves of ice tell a very different story, one of cold, of glaciers, and of light transformed. Ice caves form in several ways. Some are carved by meltwater flowing beneath glaciers, creating tunnels and chambers within the ice itself. Others are rock caves in cold climates where freezing temperatures create permanent ice formations inside. Frozen waterfalls, ice stalactites, and floors glazed with smooth, glassy ice that has persisted for centuries. The Ice Riesenwelt, or World of the Ice Giants, in the Austrian Alps near Salzburg, is the largest known ice cave in the world, stretching more than 42 kilometers into the interior of the Hochkogel mountain. It was first officially explored in 1879 by the natural scientist Anton von Posselt-Czorich, though local hunters had long known of its entrance. Inside, the cave is decorated with enormous ice formations sculpted by the flow of freezing water and the movement of cold winter air that is drawn into the lower entrances and trapped there by the geometry of the cave. In summer, warmer air rises out through upper openings, pulling cold air in below, creating a natural ventilation system that keeps the forward sections of the cave permanently frozen even as the world outside warms. The light inside ice caves is something truly remarkable. Where sunlight or artificial light enters, the ice glows with deep, luminous shades of blue, the result of the way dense ice absorbs red wavelengths and transmits blue. Walking through a glacial ice cave is like walking through the interior of a sapphire, every surface radiating a cool, ethereal light that seems to come from within the walls themselves. And yet, these caves are not permanent in the way that limestone caves are. They are sensitive to changes in temperature, and many glacial ice caves around the world are slowly retreating or collapsing as global temperatures rise. The ice that took centuries to build can vanish in decades. These are transient cathedrals, beautiful precisely because they are fragile, existing in a delicate balance between cold and warmth that the modern world is quietly disturbing. Let's rest here for a moment in the cool blue stillness and consider something extraordinary. Caves, even the deepest and most remote, are not always lifeless. In fact, some of the most remarkable creatures on Earth have evolved in total darkness, adapting to conditions that would seem utterly hostile to life as we know it on the surface. These are the troglobites, organisms that have become so specialized for cave life that they can no longer survive outside of it. The word itself comes from the Greek troglo, meaning cave, and bios, meaning life. Among the most famous troglobites is the olm, a pale, elongated amphibian found in the underwater caves of the Dinaric Alps, stretching across parts of Slovenia, Croatia, Bosnia and Herzegovina, and Italy. The olm, also known by its scientific name, Proteus anguinus, can grow up to about 30 centimeters long and has adapted to cave darkness so completely that it has lost nearly all pigmentation, giving it a ghostly, pinkish-white appearance. Its eyes, no longer needed, have become vestigial, covered by skin and no longer capable of forming images, though they retain some sensitivity to light. To compensate, the olm has developed extraordinary sensory abilities. It can detect faint electrical fields generated by the muscle movements of prey, and its hearing and sense of smell are remarkably acute. Perhaps most astonishing, the olm has an extraordinarily slow metabolism, which allows it to survive without food for up to 10 years under extreme conditions. Scientists studying the olm in Postojna Cave in Slovenia have tracked individuals that barely moved from the same spot over a span of several years. These creatures live in a world where food is scarce and unpredictable, and their strategy is simply to wait. To conserve energy with such discipline that time itself seems to lose its grip. The olm can live for over 100 years, an extraordinary lifespan for an amphibian, and it reproduces only rarely, perhaps once every 12 years or so. In the silence of the cave, surrounded by stone and still water, these ancient creatures drift slowly through an existence that is almost incomprehensibly patient. The olm is not alone in the dark. Caves around the world harbor their own communities of highly specialized organisms, each adapted to the particular conditions of its underground home. In the limestone caves of the Edwards Plateau in Texas, blind catfish glide through underground rivers, navigating by lateral line organs that detect the faintest pressure changes in the water. In the caves of Kauai in Hawaii, tiny, eyeless spiders build their webs in complete darkness, relying on vibration alone to sense when prey has become entangled. In the Movile Cave in southeastern Romania, discovered in 1986 during construction tests for a power plant, scientists found something even more extraordinary. This cave had been sealed off from the outside world for an estimated 5.5 million years. The atmosphere inside was markedly different from the air above, low in oxygen, roughly half the normal concentration, and rich in hydrogen sulfide and carbon dioxide. And yet, despite these harsh conditions, the cave was teeming with life. Researchers have identified more than 50 species living inside Movile Cave, the majority of which are found nowhere else on Earth. These include spiders, water scorpions, leeches, and various crustaceans. What makes this ecosystem so remarkable is its energy source. On the surface, nearly all life depends ultimately on sunlight through photosynthesis. But in Movile Cave, there is no sunlight and never has been, at least not for millions of years. Instead, the base of the food chain consists of chemosynthetic bacteria, microorganisms that derive energy from chemical reactions, specifically the oxidation of hydrogen sulfide and other compounds present in the cave's water and atmosphere. These bacteria form thick mats on the surface of the cave's pools, and they support an entire food web, from tiny invertebrates to predators, all thriving in a world that has never seen the sun. Movile Cave is sometimes compared to the hydrothermal vents of the deep ocean floor, where similar chemosynthetic communities flourish around volcanic fissures in complete darkness. Both environments remind us that life does not require sunlight. It requires only energy, and energy takes many forms. There is something deeply comforting about the constancy of caves. While the surface world endures storms, seasons, the passage of day and night, and the restless cycling of temperature and weather, the deep interior of a cave remains almost perfectly stable. In many deep cave systems, the temperature holds steady year-round, typically matching the mean annual surface temperature of the region above. In temperate climates, this often means a cool, constant temperature of roughly 10 to 15 degrees Celsius. The humidity in deep caves is almost always near 100%, and the air is still, undisturbed by wind or weather. This constancy has made caves invaluable to science. Speleothems, the general term for cave mineral formations, including stalactites, stalagmites, and flowstones, serve as extraordinary records of past climates. As each thin layer of calcium carbonate is deposited, it captures chemical signatures from the water, including the ratios of oxygen isotopes, which vary depending on the temperature and the source of the rainfall at the time of deposition. By carefully drilling into a stalagmite and analyzing these isotopic ratios layer by layer, scientists can reconstruct a detailed climate record stretching back hundreds of thousands of years. These records have proven crucial for understanding ice age cycles, monsoon patterns, and long-term shifts in precipitation across entire continents. In some cases, speleothem records have been used to calibrate and cross-check other climate archives, such as ice cores from Greenland and Antarctica. The caves preserve these records with remarkable fidelity because the stable conditions inside prevent the kind of weathering and erosion that would destroy similar records on the surface. In a very real sense, caves are the Earth's memory. They record what the sky was doing, what the rain carried, and how the climate shifted, all encoded in stone, in the quiet dark, waiting patiently for someone with the right tools and the right questions to come along and read the story hidden within. And so the caves remember what the surface forgets, holding their records in perfect stillness, asking nothing in return. And yet, caves have been more than geological archives. For as long as humans have existed, we have been drawn to caves, seeking shelter, seeking safety, and seeking something else, something harder to name. The oldest known evidence of human cave use stretches back hundreds of thousands of years. Caves provided our distant ancestors with natural shelter from predators, from weather, and from the harsh extremes of Ice Age winters. But some caves were used for something far beyond mere survival. Deep inside certain caves, in chambers that require crawling through narrow passages, climbing over rock falls, and navigating in total darkness, our ancestors left paintings on the walls. The cave paintings of Lascaux in the Dordogne region of France, discovered in 1940 by 4 teenagers, date to approximately 17,000 years ago. They depict horses, aurochs, deer, and other animals in remarkable detail, rendered with a sophistication and an artistic sensitivity that still astonishes researchers. Even older are the paintings of Movile Cave, also in France, discovered in 1994, which have been dated to roughly 36,000 years ago, making them among the oldest known examples of figurative art. What strikes many scholars is not just the skill of these paintings, but their location. These images were not placed near the cave entrances where people lived and worked. They were created deep inside, in places that were difficult and even dangerous to reach, in spaces that would have required torches or simple oil lamps to illuminate. This suggests that the act of creating these images was not casual or decorative. It was deliberate, perhaps ritualistic, carried out in the profound silence and darkness of the deep cave interior. Some researchers have proposed that the caves themselves may have held spiritual significance for these early humans, that the journey into the dark was itself meaningful, a passage into another world. We cannot know their thoughts, of course. But standing before those ancient images, painted by the light of a flickering flame in the deepest silence imaginable, it is difficult not to feel a connection across the vast gulf of time. Let us descend once more, past the painted chambers and the archaeological layers, past the familiar limestone, into something truly vast. Some of the deepest caves on Earth reach down more than 2 kilometers below the surface. The Veryovkina cave in the Arabica Massif of Abkhazia, along the eastern coast of the Black Sea, holds the current record as the deepest known cave in the world, reaching a surveyed depth of 2,212 meters. To reach the bottom of this cave requires days of technical caving, rappelling down vertical shafts, some of them hundreds of meters deep, squeezing through tight passages, wading through underground rivers, and camping in the dark at underground bivouac sites along the way. The temperature at depth is cool and constant, and the darkness is absolute. There is no ambient light of any kind, not the faintest glow, not the dimmest star. This is a darkness so complete that the human eye, no matter how long it waits, will never adjust to it. It is the darkness that existed before fire, before language, before life itself. For the explorers who venture this deep, the experience is often described as profoundly transformative. The normal rhythms of the surface world, sunrise, sunset, meals at regular hours, the feeling of open sky, all of these disappear. Time becomes elastic. Without external cues, the body's circadian rhythm begins to drift. And some cavers report losing track of whether it is day or night above, whether they have been underground for 2 days or 4. This effect was famously studied by the French geologist Michel Siffre, who in 1962 spent 2 months alone in the Scarasson cavern in the French-Italian Alps without a clock or any contact with the surface. His internal clock gradually shifted, and he experienced cycles that were sometimes as long as 48 hours. When he was finally brought out, he believed far fewer days had passed than actually had. Caves, it seems, can dissolve not only rock, but our very sense of time, leaving us suspended in a kind of eternal, gentle present. Somewhere in that dissolving of time, in that suspension between waking and sleeping, between the surface world and the deep world, let us pause and think about sound. Caves have their own acoustics, shaped by the geometry of their chambers, the texture of their walls, and the presence or absence of water. In some caves, the silence is so profound that visitors report hearing their own heartbeat, their own blood moving through their body, as if the body itself becomes audible in the absence of all other sound. In others, the acoustics are extraordinary. The Luray Caverns in Virginia contain a formation called the Great Stalagmites Organ, an instrument created in 1956 by Leland Sprinkle, a mathematician and electronics engineer. He spent 3 years testing stalactites throughout the cave, tapping each one and listening to its pitch, selecting those that produced clear, resonant tones. He then connected small rubber-tipped mallets to an electronic console so that when a key is pressed, a mallet strikes a stalactite somewhere in the cave, and the resulting tone reverberates through the entire chamber. The organ covers roughly 14,000 square meters of the cave, making it perhaps the largest natural musical instrument in the world. But even without human intervention, caves produce their own music. The sound of dripping water, which may seem monotonous at first, reveals itself over time to be remarkably complex. Each drop producing a slightly different pitch depending on the height from which it falls, the size of the pool below, and the shape of the surrounding rock. In very large chambers, these individual drops combine into a subtle, layered rhythm, a kind of percussion that has been playing continuously for thousands of years, with no audience and no conductor, just the quiet, patient work of gravity and water. If you listen carefully now, in the stillness of this moment, you might imagine that you can hear it, a single drop falling through cool air, landing softly on stone, and then the long, gentle silence that follows before the next drop falls. Not all caves are carved from limestone, and not all are shaped by water alone. Lava tubes are a different kind of cave entirely, formed not by dissolution, but by the flow of molten rock. When a river of basaltic lava flows across the surface, the outer layer cools and hardens, while the molten interior continues to drain downhill. When the eruption stops and the lava drains away, it leaves behind a hollow tube, a smooth-walled tunnel that can stretch for many kilometers. The Kazumura Cave on the Big Island of Hawaii is the longest and deepest known lava tube in the world, stretching approximately 65 kilometers and descending roughly 1,100 meters from its highest point to its lowest. Its walls are smooth and rounded, lined with a glassy veneer of cooled basalt, and in places, delicate lava stalactites hang from the ceiling, thin, pointed formations created when the last remnants of molten rock dripped downward before solidifying. These are sometimes called lavasicles, and unlike their limestone counterparts, which take millennia to form, they were created in minutes or hours as the lava drained. On other worlds, lava tubes may be even more significant. Scientists have identified what appear to be collapsed lava tubes on the surface of the Moon and Mars, visible as chains of pit craters and linear depressions called rills. Current research suggests that lunar lava tubes may be enormous. Some estimates propose widths of hundreds of meters, far larger than any lava tube on Earth, because the Moon's lower gravity allows much larger voids to remain structurally stable. These lunar lava tubes have attracted serious interest as potential sites for future human habitation. A lava tube on the Moon would offer natural protection from micrometeorites, cosmic radiation, and the extreme temperature swings of the lunar surface, where temperatures can range from roughly 120 degrees Celsius in sunlight to minus 170 in shadow. Beneath the silent, airless surface of the Moon, ancient lava tubes may one day shelter the first permanent human settlements beyond Earth. Caves, once again, offering refuge, just as they did for our ancestors on this world so long ago. We drift deeper into the night and deeper into the quiet of the underground world. Consider the role that caves have played in our understanding of ourselves. In caves, we have found some of the most important fossils in the story of human evolution. The Caves of the Cradle of Humankind, a UNESCO World Heritage Site in South Africa's Gauteng province, have yielded fossils of multiple species of early hominins, including Australopithecus africanus, and more recently, the remarkable discovery of Homo naledi in the Rising Star Cave system. In 2013, a team led by the paleoanthropologist Lee Berger recovered more than 1,500 fossil elements from a nearly inaccessible chamber deep within the cave, representing at least 15 individuals. The chamber could only be reached through a narrow chute, roughly 18 centimeters wide, and the excavation required a team of slender, highly skilled cavers to access it. Homo naledi, as the species was named, displayed a mosaic of features: a small brain, curved fingers suited for climbing, but also relatively modern-looking feet and legs adapted for walking upright. The species has been dated to roughly 236,000 to 335,000 years ago, meaning it existed alongside or near the time of early Homo sapiens in Africa. What remains deeply debated is how the bodies came to be in that remote chamber. Some researchers, including Berger, have proposed that Homo naledi may have been deliberately disposing of their dead in the cave, a behavior that, if true, would suggest a level of symbolic or ritualistic thinking previously associated only with much larger-brained species. This hypothesis remains controversial, and other explanations, such as accidental entrapment or water transport of the remains, have been offered. The question is not yet settled, but standing at the edge of that narrow chute, looking down into the darkness where those ancient bones rested for hundreds of thousands of years, one feels the weight of a mystery that reaches to the very heart of what it means to be human. There is one more world beneath the surface that we have only begun to explore. The world of underwater caves, flooded cave systems, known as phreatic passages, or, when accessible to divers, as underwater caves, represent some of the most challenging and dangerous environments that humans have ever entered. The Yucatan Peninsula of Mexico is home to the longest known underwater cave systems in the world. The Sistema Sac Acton, which was connected to the neighboring Sistema dos Ojos in 2018, now stretches over 370 kilometers of surveyed underwater passages, making it the longest known underwater cave on Earth. These caves were carved during ice ages when sea levels were much lower and the water table sat far below the current level. When sea levels rose, the caves flooded, and the crystal-clear water now fills passages that were once dry. Diving in these caves is an experience of almost surreal beauty. The water is so clear that visibility can extend for 100 meters or more, and sunlight filtering through cenotes, natural sinkholes that connect the caves to the surface, creates shafts of brilliant blue-white light that pierce the darkness like spotlights on a stage. Within these passages, divers have found remarkable things. Ancient stalactites and stalagmites that clearly formed in air but now stand submerged, silent witnesses to the great changes in sea level that accompanied the ice ages. In the deeper reaches, far from any cenote, the darkness returns, and the caves take on a solemn, cathedral-like quality. The water absolutely still, the formations preserved in a state of perfect suspension. These underwater caves have also yielded extraordinary archaeological finds, including the remains of Pleistocene megafauna and some of the earliest known human remains in the Americas. The skeleton known as Naya, discovered in an underwater cave called Hoyo Negro on the Yucatan Peninsula, has been dated to approximately 12,000 to 13,000 years ago. She likely fell into the cave when it was dry, long before the rising waters sealed her resting place. Now she lies in the dark, in the clear, still water, as she has for thousands upon thousands of years. Now, as the night deepens and the world above grows quieter, let us return to the surface one last time and reflect on what the caves have shown us. They have shown us patience, the patience of water dissolving stone one molecule at a time, the patience of crystals growing one imperceptible layer per century, the patience of the Olm drifting motionless through its dark and silent world. They have shown us resilience, life thriving in sealed chambers without sunlight, entire ecosystems running on chemistry alone, organisms adapting to conditions that would seem impossible from the vantage point of the surface. And they have shown us something about ourselves. For hundreds of thousands of years, human beings have been drawn to caves, not only for shelter, but for something deeper and more difficult to articulate. We painted on their walls. We buried our dead in their chambers. We descended into their darkest reaches, carrying nothing but small, flickering flames. And there, in the silence, we created art. We told stories, and perhaps, in ways we can only imagine now, we dreamed. There is a quietness to caves that goes beyond mere absence of sound. It is a quietness that feels intentional, as if the earth itself is holding still, listening, waiting. And perhaps that is why caves have always called to us. They offer something that the surface rarely does, a space apart from the noise of living, a place where time slows, where the air is cool and still, and where the darkness is not frightening, but sheltering. Tonight, as you lie still and let the weight of the day dissolve, imagine that you are resting in a place like that, a gentle, sheltering darkness, with the sound of a single drop of water falling somewhere nearby, and all the time in the world stretching out before you, soft and unhurried, like the slow growth of stone. Let us linger for a moment on the subject of time, because caves are, in a very real sense, libraries of deep time. Their pages written not in ink but in stone and mineral, and the slow, patient work of water. Consider the oldest known cave systems on Earth, places like Jenolan Caves in Australia, where geologists have estimated that some passages may have begun forming over 300 million years ago, during the Carboniferous period, when the continents had not yet assumed the shapes we know today. 300 million years, a number so vast that it resists the grasp of the human imagination, and yet the caves remain, carrying that ancient memory in every fold of rock, every curve of tunnel, every layer of sediment compressed beneath the weight of geological ages. In some caves, scientists have discovered minerals that are extraordinarily rare on the surface of the Earth. Lechuguilla Cave in New Mexico, for example, is home to formations of aragonite, hydromagnesite, and selenite that have grown in near-total isolation from the outside world, shaped by sulfuric acid dissolving limestone from below, rather than by the more common process of carbonic acid seeping from above. This process, known as sulfuric acid speleogenesis, creates chambers of astonishing size and passages lined with crystals that glitter like frozen starlight. And because these caves were sealed for millions of years, Their formations are among the most pristine ever studied, untouched by wind, rain, or the slow erosion of surface weather. There is something deeply humbling about standing, or imagining yourself standing, in a passage that has been dark and silent for longer than mammals have walked the earth. The rock remembers what the world above has long forgotten. The crystals grew in a darkness so absolute that the concept of light had no meaning within those walls. And still the water moved, still the minerals precipitated, still the cave continued its slow, imperceptible work of becoming, one molecule at a time, across spans of time that dwarf the entirety of human civilization. And yet, even in the deepest silence and the longest darkness, caves are not lifeless. Far from it. In the discipline of biospeleology, the study of life within caves, researchers have discovered ecosystems so strange, so beautifully adapted to absolute darkness, that they challenge our assumptions about what life requires in order to persist. Consider the olm, sometimes called the proteus or the human fish, a pale, elongated amphibian found in the underwater caves of the Dinaric Alps in southeastern Europe. The olm has lived in darkness for so long, current evidence suggests millions of years, that its eyes have regressed beneath the skin, no longer capable of forming images. Its body has lost nearly all pigmentation, giving it an almost ghostly, translucent appearance. And yet, it thrives, navigating its lightless world through an extraordinary sensitivity to chemical and electrical signals in the water around it. Some researchers believe the olm may live for over a century, an astonishingly long lifespan for an amphibian, likely a consequence of its extremely slow metabolism in the cool, stable waters of the cave. In other cave systems, scientists have found entire communities of organisms that derive their energy not from sunlight, as nearly all surface ecosystems do, but from chemical reactions, a process known as chemosynthesis. In Movile Cave in Romania, sealed from the atmosphere for roughly 5.5 million years, bacteria oxidize hydrogen sulfide and other chemicals to produce energy, forming the base of a food web that supports spiders, leeches, water scorpions, and other invertebrates found nowhere else on Earth. This cave, discovered in 1986 during construction work, contained an atmosphere rich in hydrogen sulfide and carbon dioxide and almost devoid of oxygen, and yet life had not merely survived there, it had diversified and flourished. These discoveries carry profound implications for the search for life beyond Earth, because they demonstrate that life does not require sunlight, does not require fresh air, does not require the familiar conditions of the surface world we know. Life, it seems, requires only chemistry, water, and time. Now, let your thoughts drift gently upward from those hidden ecosystems, rising through the layers of stone, through the veins of water threading silently between the rock, and settle upon a different kind of wonder, the way that caves have shaped human consciousness itself. For as long as our species has existed, and perhaps before, caves have been places of shelter, ceremony, and art. The painted caves of Lascaux in southwestern France, discovered in 1940, contain images of horses, aurochs, deer, and other animals rendered with such grace and confidence that they remain among the most celebrated works of art in human history. Radiocarbon dating and other techniques suggest that many of these paintings are approximately 17,000 years old, though some scholars believe certain marks in other caves may be considerably older still. In the Chauvet Cave, also in France, discovered in 1994, paintings of lions, rhinoceroses, and mammoths have been dated to roughly 36,000 years ago, making them among the oldest known figurative artworks anywhere on Earth. Imagine the hands that made these images, working by the flickering light of animal fat lamps or simple torches deep within the mountain, surrounded by absolute silence, except for the drip of water and the soft sound of breath. These artists chose the deepest chambers, the most difficult passages, places that required effort and courage to reach, suggesting that the act of painting was not casual, but deliberate, perhaps ceremonial, perhaps sacred. And in the caves of Sulawesi in Indonesia, researchers have found stenciled handprints and animal figures dated to at least 45,000 years ago, revealing that this impulse to mark the darkness, to leave a record of oneself in the silent stone, emerged independently across vast distances of geography and culture. Caves, it seems, called to something deep within the human mind, a need to reach into the dark and leave behind a trace, a signal, a whisper across the millennia that says simply and powerfully, we were here, we saw, we felt, and we reached for meaning in the silence. Perhaps the most extraordinary thing about caves is not what they contain, but what they teach us about stillness itself. On the surface of the earth, everything is in motion. Wind moves across plains, rivers carve their valleys, seasons turn the forests from green to gold and back again. But deep underground, in the innermost chambers of a cave, the air barely stirs. The temperature holds steady, year after year, decade after decade, hovering within a degree or two of the local annual average. In many deep caves, this temperature rests between 12 and 15 degrees Celsius, a perpetual cool twilight of the atmosphere that neither summer's heat nor winter's frost can reach. The humidity often approaches 100%, and the silence is so complete that researchers who spend extended periods underground have reported hearing their own heartbeat, the rush of blood in their ears, the faint creak of their own joints. In 1962, the French geologist Michel Siffre conducted one of the earliest deep cave isolation experiments, spending 2 months in the Scarasson cavern in the Maritime Alps, cut off from all cues of day and night. Without sunlight, clocks, or any external rhythm, his perception of time began to drift. His sleep-wake cycle lengthened, and he gradually lost all accurate sense of how many days had passed. When his team signaled that the experiment was over, Siffre believed he had been underground for roughly 25 days, fewer than had actually elapsed. His experience demonstrated, among other things, how profoundly our sense of time depends upon the rhythms of light and dark that caves so thoroughly erase. In that stillness, the boundaries between 1 hour and the next dissolve, and the mind enters a kind of quiet suspension, untethered from the clock, drifting in a space where only the body's own faint rhythms remain. And perhaps that is a fitting image to carry with you now, as you lie in your own quiet darkness, a gentle cave of blankets and breath, where time softens, the world recedes, and stillness becomes its own kind of shelter. Consider for a moment the water that moves through caves, for it is water that is both sculptor and storyteller, carving the narrative of deep time into every surface it touches. A single drop of rainwater, falling on the surface above a limestone cave, begins its journey by absorbing carbon dioxide from the soil, becoming a weak carbonic acid, gentle enough to hold in your hand, and yet persistent enough to dissolve solid rock over centuries. That droplet seeps downward through hairline fractures, through pores in the stone no wider than a human hair, dissolving calcium carbonate molecule by molecule, widening passages that were once invisible to the naked eye. Over tens of thousands of years, those invisible fractures become channels, and those channels become streams, and those streams carve the grand galleries and cathedral chambers that take our breath away. The water remembers everything it has touched. Scientists can analyze the chemistry of cave drip water and read within it the story of surface conditions stretching back hundreds of thousands of years. The ancient rainfall patterns, the temperature of vanished seasons, the type of vegetation that once grew in the soil above. In this way, caves become libraries of climate history, their mineral deposits recording environmental changes with a fidelity that rivals ice cores and ocean sediment records. And the water does not merely dissolve. When a droplet, saturated with dissolved minerals, emerges from the ceiling of a cave into an air-filled chamber, something beautiful happens. The slight change in carbon dioxide concentration causes the water to release a tiny fraction of its dissolved calcium carbonate, depositing it as a microscopic crystal of calcite. One droplet leaves behind a ring of minerals so thin it is nearly invisible. But the next droplet follows, and the next, and the next, each adding its own imperceptible contribution. Over thousands of years, those contributions accumulate into stalactites hanging from the ceiling like frozen chandeliers, growing at rates that can be as slow as 1 centimeter per century. Beneath them, where the droplets land and splash, stalagmites rise from the floor in patient counterpoint, built from the same mineral rain. And in rare, patient cases spanning hundreds of thousands of years, a stalactite and a stalagmite meet, fusing into a single column that bridges floor and ceiling, a monument to the extraordinary patience of geological time. Stalactites and stalagmites, as wondrous as they are, represent only a small fraction of the mineral formations that caves can produce. The broader term for these deposits is speleothems, from the Greek words for cave and deposit, and they come in an astonishing variety of shapes that seem to defy the simple physics of dripping water. There are flowstones, smooth cascading sheets of calcite that coat cave walls and floors like frozen waterfalls, their surfaces rippled and layered in bands of amber, cream, and rust, each band recording a different era of mineral-laden water flowing across the stone. There are cave pearls, small rounded spheres of calcite that form in shallow pools, where dripping water agitates a tiny grain of sand or a fragment of bone, rolling it gently over years and decades until layer upon layer of mineral coats it into a smooth, lustrous orb, sometimes no larger than a pea, sometimes as wide as a golf ball. And then there are the formations that seem almost impossible, the ones that appear to ignore gravity entirely. Helictites are among the most mysterious of all speleothems, twisting, curling tendrils of calcite that grow in seemingly random directions, spiraling sideways, curving upward, branching like the roots of some crystalline plant. For many years, their growth mechanism puzzled scientists. Current evidence suggests that capillary forces, the same forces that draw water up through a narrow straw, push mineral-laden water through microscopic channels within the crystal itself, allowing the helictite to extend in whatever direction those internal channels happen to lead, regardless of gravity. The result is formations of breathtaking delicacy, forests of translucent white filaments no thicker than a pencil lead, curling and looping through the cave air like calligraphy written by the earth itself. Some of the finest examples in the world can be found in Lechuguilla Cave in New Mexico, a cave so pristine and so richly decorated that access is strictly limited to approved scientific expeditions, preserving its formations in a state of near-perfect stillness. Each of these speleothems is, in its own quiet way, a clock, a thermometer, and a rain gauge, encoding the environmental conditions of its birth within the chemistry of its crystalline layers. And yet, perhaps the most humbling caves of all are those we may never see. the ones that exist beyond the reach of any human expedition, sealed away in total isolation for millions of years. In the year 2005, researchers in Romania gained access to Movile Cave, a small limestone cavity near the Black Sea coast that had been sealed from the outside atmosphere for an estimated 5.5 million years. The air inside was remarkably different from the air we breathe, containing only about half the oxygen concentration found at the surface and rich in hydrogen sulfide and carbon dioxide. And yet, against all expectation, the cave was alive. Scientists discovered a thriving ecosystem of approximately 50 species, many of them found nowhere else on Earth, including spiders, water scorpions, leeches, and tiny crustaceans, all sustained not by photosynthesis or by nutrients washed in from the surface, but by chemosynthesis, a process in which specialized bacteria derive energy from chemical reactions, particularly the oxidation of hydrogen sulfide. These bacteria form the base of a food web that exists in complete independence from the sun, a parallel biology running on the chemistry of the Earth itself. Movile Cave offered a profound insight, a demonstration that life does not require sunlight, does not require the familiar green machinery of photosynthesis, but can sustain itself on the raw chemistry of rock and water and volcanic gas. Some astrobiologists have suggested that environments like Movile Cave may offer the closest earthly analogy to conditions that might exist beneath the surfaces of other worlds, perhaps beneath the icy crust of Jupiter's moon Europa, where a liquid ocean is believed to lie in contact with a rocky seafloor, potentially providing the chemical gradients that chemosynthetic life would need. We do not yet know whether such life exists beyond our planet, but the silent ecosystems of sealed caves remind us that biology is more resourceful and more tenacious than we once imagined, finding a way to persist in conditions that seem utterly inhospitable, drawing energy from the darkness itself. And as you rest now, breathing slowly, let that thought settle gently into your awareness, the knowledge that even in the deepest silence, in places untouched by light for millions of years, life endures, patient and quiet and profoundly resilient. There is another presence within caves, one that has endured in silence for far longer than any human memory, and that is the presence of life itself. Deep beneath the surface, in passages where no sunlight has reached for millions of years, entire ecosystems have quietly persisted, shaped by conditions so extreme that they challenge our very understanding of what it means to be alive. Scientists refer to these creatures as troglobites, organisms that have adapted so completely to the subterranean world that they could never survive on the surface. And yet, within that permanent darkness, they have flourished in ways both strange and beautiful. Consider the olm, a pale amphibian found in the limestone caves of southeastern Europe, particularly in the karst regions of Slovenia, Croatia, and Bosnia. The olm has no functional eyes, its vision having receded over countless generations until only vestigial structures remain beneath its translucent skin. Its body is ghostly white, or sometimes a delicate pinkish hue, its elongated form drifting through underground rivers with an almost ethereal grace. It can live for more than a century, an extraordinary lifespan for an amphibian. And it is capable of surviving without food for several years by slowing its metabolism to a pace that seems barely distinguishable from stillness. The olm navigates not by sight, but by sensing subtle electrical fields generated by the muscles of its prey, a kind of biological sonar refined over millions of years of isolation. And the olm is only one thread in a vast tapestry of cave-adapted life. In caves across the world, researchers have discovered blind fish, translucent spiders, ghostly white crayfish, and bacteria that derive their energy not from sunlight, but from chemical reactions deep within the rock, a process known as chemosynthesis. These chemosynthetic microorganisms form the base of food webs entirely independent of the sun, entire communities sustained by the slow chemistry of minerals and water. In Romania's Movile Cave, sealed from the surface for approximately 5.5 million years, scientists discovered an ecosystem of more than 50 species, most of them found nowhere else on Earth, all thriving in air heavy with hydrogen sulfide and almost devoid of oxygen. And if the life within caves astonishes us, so too does what caves preserve of lives long past. For as long as human beings have sought shelter, they have been drawn to the mouths and chambers of caves. And in doing so, they have left behind traces of their inner worlds that endure across tens of thousands of years. The painted caves of Europe remain among the most moving testaments to early human consciousness. In the Movile Cave of southern France, discovered in 1994, images of lions, horses, rhinoceroses, and mammoths adorn the walls in sweeping, confident lines, rendered with a sophistication that stunned the scientific community. Radiocarbon dating places some of these paintings at approximately 36,000 years old, making them among the oldest known examples of figurative art in the world. The artists used charcoal and red ochre, blending pigments and exploiting the natural contours of the rock to give their animals a sense of movement, of breath, of life suspended in stone. In the cave of Lascaux, also in France, discovered in 1940, the so-called Hall of the Bulls presents enormous aurochs, horses, and deer in a sweeping panorama that some researchers have compared to a cathedral ceiling. And far to the south, on the Indonesian island of Sulawesi, hand stencils and animal figures have been dated to at least 45,500 years ago, suggesting that the impulse to mark the walls of caves arose independently in distant corners of the human world, or perhaps travelled with our ancestors as they migrated across continents. What is remarkable is not merely the age of these images, but their emotional resonance. These were not idle decorations. Some researchers believe they may have served ritual or spiritual purposes, created in the flickering light of animal fat lamps, deep within chambers that required crawling through narrow passages to reach. The caves themselves may have been chosen for their acoustics, their echoing chambers amplifying chant or song. And so the silence of caves has long been a silence that humans sought out, a silence in which something sacred could be spoken, or painted, or simply felt in the presence of the dark. Caves are still there, of course, beneath the mountains and the plains, beneath the forests and the sea. They do not need us to witness them. They do not need our light or our attention. They simply continue, as they have for millions of years, growing and changing in their own quiet way, drop by patient drop. And you too are settling now, sinking gently into your own kind of stillness. The thoughts of the day are receding, like the surface world fading above as you descend into comfortable dark. There is nothing to hold on to, nothing to worry about, just the quiet rhythm of your breathing, steady and slow, like the steady drip of water in a cave that has been counting the centuries without hurry and without end. Let the silence hold you. Let the dark be kind. Sleep now, gently, in the shelter of the earth. If tonight's journey beneath the earth brought you peace, we would love for you to stay a little longer. A gentle tap on the subscribe button means you will find us here each night, with a new story, a new world to explore, a new path toward rest. Thank you for spending your night with Let's Learn While You Sleep. Subscribe and come back tomorrow night. We'll be here. Sleep well.